Good evening. So let me share my screen. Now we should start with tutorial 8. Okay, so for the previous tutorials on Monday, we have complete until question 1 in tutorial 8. So let's continue. So describe the terms frequency masking and temporal masking of two or more audio signal. Briefly explain the cause of this masking. So um, before we go for the answer, yeah, perhaps we need to go for answer first. Later only explain. Okay, let me pick someone to answer. Yong Chuan Lim. This one I think is okay to put in the chat box. You can put in the chat, put the answer in the chat box. Yong Chuan Lim, are you there? Maybe you can share your answer. Oh, thank you. Frequency masking is referring to the frequency domain phenomenon where a low-level signal can be inaudible by a simultaneously occurring stronger signal, where the masking should be close frequency. Okay, the masker will masking area, will form a masking area and low-level signal with other frequency that within this area, within this area is it? Within this area will be masked. Temporal masking. Oh yeah, I saw it. Temporal masking is referring to the time domain phenomenon where a low-level signal can be inaudible by simultaneously occurring stronger signal that appear in short. Temporal by a simultaneously occurring stronger signal that appear in short period of time will be masked. Okay, okay. Thank you for your answer. So this one I think is quite easier because I've been repeating this two uh, quite frequently. So in this is in chapter 8, I think. Yeah, C8, chapter 8. Chapter 8 and 9 is about audio processing. 10 and 11 is about video processing. So describe the terms. Thank you for your answer. Is correct. So describe the terms frequency masking and temporal masking of two or more audio signal. Briefly explain the cause of this masking. Okay, again, how extensive is your answer, and also perhaps do you need to give example? Would be based on the question. The marks given. If the marks given is very lengthy, for example, I would consider 4 marks and above is considered quite high. Um, yeah, 4 marks and above should be considered quite high. So if you have 4 marks, so maybe you need to consider to put in um, the example. For example, in what condition you might have this issue. Okay. If not, then should be simple definitions, or simple explanation should be sufficient. So frequency masking, when an audio signal consists of multiple frequency, the sensitivity of the ear change with the relative amplitude of the signal. If the frequencies are close and the amplitude of one is less than the other close frequency, so the frequency with a lower amplitude that is below the threshold of audibility may not be heard. With the range of closeness for frequency masking, the critical band depends on the frequency and relative amplitude. I will revise. I will do the revision in this chapter. Don't worry, because I think this chapter is a bit, at least to me, I think would be a bit complex as compared to the rest of the chapter. So perhaps I think it's worthwhile to do the revisions again. Okay, so temporal masking. After the ear hear a loud sound, it takes a further short while before it can hear a quieter sound. Okay, so both answer given by our friends is okay. Yeah, basically the frequency masking and the temporal masking is like um the frequency masking is more, I mean, the x-axis is in terms of frequency, but the temporal masking, the x-axis is in terms of t, which is a time taken. Usually we put it in second lah, and the y-axis would be the amplitude or the intensity. Okay, so frequency masking and temporal masking somewhat can be happens from one phenomenon. For example, um, hap- a bomb uh, a boom maybe not a good idea. Maybe after you go for a concert, okay, you go for a concert. So after you just exit the concert, so perhaps it can affect both the frequency and temporal because the frequency would be would be focusing on the frequency of the music itself, but temporal would be focusing on the time taken itself. So basically, from one phenomenon, it's unlikely to have only one masking, which is either frequency or temporal. I would say it's quite rare. Yes, some incident might be, but usually you would have a shaded area where both of this frequency and temporal masking happens together. Maybe with um, different period of times, but would be more or less both would happen. Okay, cause to both types of masking, within the human ear, there are tiny hair cells that are excited by the air pressure vibration. Always remember the audio or the any sounds energy is acoustic. So um, the acoustic energy require the I mean a medium because the vibration require mediums. Okay, if without medium, so nothing can vibrate because the vibration is is referring to the atoms in the air and maybe atoms in any solid or liquid phase. So without the medium, you cannot transfer any acoustic energy. So that is why in vacuums or outer space, there is no sound. Okay, so air pressure vibrations, different hair cell respond to different ranges of frequency. So frequency masking occur because excitation of one frequency further excitation by a less stronger, a strong similar frequency are not possible of the same group of cells. Then temporal masking occur because the hair take time to settle after excitation to respond time. Um, Actually, not only the auditory system, even though our impulse is the same, that is why you would have a small drop off when you that is why when you would have a small drop off this area. I mean, in this drop off impulse is so called the resting impulse. So you will unlikely to respond or delay in response. But of course, this impulse, I mean, the drop off impulse is very short in time taken. Okay, so the same thing lah. Actually all those withdrawal effect. For example, you taking someone are taking drugs, and then why there is a withdrawal effect. This can explain it because the dose that you take you already immune. So the same dose you take will no longer give you the pleasant feeling. So that is and this will cause the withdrawal effect. So that is why those that take that maybe take drugs or whatever else, or maybe alcohol, they would have withdrawal effects and they need to consume more and more, higher and higher amount in order to give the same pleasant feeling. Okay, so this is so-called the withdrawal effect because our body will get used or saturated with a certain amount. This is how the body react lah. Okay, so the same thing here, when it happens to auditory system, so our ear is not able to keep on responding to different level of frequency or different level of signal in a very short time. We need a transition period to move and restore back to the original state, and then we respond, continuous respond to new stimuli Okay, if without this transition period, I mean, if this transition period is very long, so-called a delay, delay in response. Okay, so these two are the I mean are the motivations and also um, how it comes to the impact compression in I mean using the psychoacoustic model and etc. Okay, so you need to know you need to know the reason, I mean, how we actually comes out with the psychoacoustic model and why the psychoacoustic model consider the frequency masking, temporal masking, and etc. And each different level would cover a different masking. If not mistaken, if not mistaken, the first layer cover, I mean, MPEG 1, 2, 3, three layer, right? So MPEG first layer is consider only the frequency masking. Second layer consider the temporal masking and frequency masking, and third layer consider these two masking and other more sophisticated masking. Okay, so this is how the psychoacoustic model function and how the rules out. I mean, um, more and more sophisticated filter are being used in order to compress and remove redundancy information in our audio file. Okay, so but nonetheless, usually we are using MP3 lah, which is the third layer. Mm. So the third layer will consist of frequency, temporal, and other sophisticated uh, filter. Okay, briefly discuss how impact audio conversion exploit the psychoacoustic phenomenon. Oh, I think I have already explained this one. It's okay. Maybe we can invite someone to provide us the answer. Let me check. Lim Chun Wei, are you there, Lim Chun Wei? Okay. Maybe Chie. Yeah, hi. Maybe you can put your answer in the chat box. Mm. Uh, of course, if you want to share screen is okay. Oh, all right. Thank you. Due to the frequency and temporal masking, the low-level signal within masking area will be masked and become inaudible by human. MPEG takes an advantage of this phenomenon in constructing a large multi-dimensional lookup table and translate the data using a few bits. Okay, so basically, I mean, um, I mean, the psychoacoustic model is actually um, mimic. I mean, yeah, maybe I put it like this. In short, the psychoacoustic model is to perform the frequency and uh, exploit the frequency and also temporal masking. Since psychoacoustic model is meant to remove redundance or any redundancy informations, so we will actually, I mean, the psychoacoustic model is actually determining which information is fall within the masking. Okay, so the because masking are those information signal which is inaudible to human, right? So uh, we will focus for example, MPEG layer 3, they have this layer has the uh, frequency masking and also consider the frequency masking and also the temporal masking. So basically, the impact layer 3 will find out which signal is within the masking area for frequency masking and fall within the area of temporal masking. So after they identify these informations, they will remove this information. So by removing these informations, we would have extra bit because originally they are original bit, right? For example, the file size is maybe 1 GB. So after removing that, maybe you have 0.2 GB left out. So the 0.2 GB would be allocated to another, I mean, those which is more useful, which is the next the next in the block diagram. I think it's bitrate transformations. You have a PCM. something like this. This is the psychoacoustic model. So after this one, both of these would join together, right? So in this region, after joining together, this psychoacoustic model would decide what to rule out, what to eliminate. And then after elimination, you would add extra bit. So this extra bit is going to allocate to those useful information. Is this like you expanding the sensitivity uh, in describing the useful data? For example, you have 8-bit you have 8-bit images, so it is only in grayscale, right? So since if you allocate another 16-bit to that image, so that image is eventually become a true color or RGB images. So it's very normal, right? The RGB images would have better quality of image. Can express the finest texture. The image information is maybe enriched enriched from when compared to the original, the grayscale one lah. Okay, you would be enriched by more and more because you have extra pixel to demonstrate or to display your color, your features and etc. So the same thing happens here. So basically all those extra bits are meant to pass out to the one with least bit lah. Okay, still remember the mass to noise ratio. But nonetheless, I need to refer back to the lecture notes because this is what I can recall. Okay, because now, maybe later on I will revise this one with you all. So we identify the one with the less bit and allocate the extra bit to that particular information until this extra bit all use up. Okay, so this is how we actually perform the psychoacoustic and how we manage the extra bits after we after we have rule out all the redundancy information. Okay, thank you for your answer, Chie. Yeah, I over here got. Okay, so let me explain the PZM here. So after you have PZM, you have psychoacoustic model, right? So from here, bit allocation, quantizing, and coding. So basically, this block is to determine what to drop, like what I mentioned just now, what to drop. And after what to drop, you would have extra bit, and then you would assign the bit you will assign the bit to those informations which is useful or audible lah. Simply speaking, it's just audible to human. And then until all the extra bits that you rule out just now is being fully utilized. Okay, so basically unpack you some perceptual coding concept. Perceptual is meant actually the perceptual here is referring how human perceive this audio. Okay, as I mentioned, human is the main character in multimedia, because multimedia, of course, you have we have different domain. If let's say you want to training a deep learning model, the deep learning model is meant for machine vision, not really machine vision, but to understand by the machine. Okay, so the informations within the deep learning model may or may not be understood by human. Okay, but in terms of multimedia, the center is always the human, especially the layman. Okay, not really the expert. But of course, inclusive lah. Everyone is inclusive lah. But nonetheless, what I want to highlight is that the center of the multimedia is always human. Okay, it is to enrich the engagement of human senses, engagement of human interactions with the multimedia. So it is not meant to, play around with just the machine or internal processing. No, that is not the core of multimedia. Okay, so all the perception or perceptual, all this model is based on, you will find that it's based on human being. Okay, everything is actually derived from the limitation of our eye, our ear, and etc. Okay, so the perception is how we actually perceive or how we actually behave towards different kind of signal or different kind of data. Then this system is actually mimic what we can listen and exploit our limitation. So this is so-called the psychoacoustic model. So bandwidth is divided into frequency subband using a bank of analysis filter. So this is what it's doing here. And each analysis filter using a scaling factor of subband max amplitude for psychoacoustic model. So FFT or DFT use signal to mass ratio used for frequency below a certain audible threshold. So again, I want to highlight is that this model is a general model. Again, this model is a general model, which means in real case, or in real applications, the real model of the encoder for different layer is different. Okay, for example, MPEG layer 1, MPEG layer 2, MPEG layer 3. The layer, the block diagram is different. Okay, this is just the common, maybe I should say block diagram, common block diagram for the uh, encoder. Okay, and in audio processing, the encoder and decoder, the encoder will be very complex, somewhat to be very, very complex. But the decoder usually is very simple. Okay, so this is, I think in the lectures I did include the sample of MPEG layer 1, MPEG layer 2, and MPEG layer 3. But for the encoder, all are the same. Okay, so which means most of the effort in compressing or processing the audio is in the encoder, not in the decoder. Okay, basically decoder is to revert the what happened here. Okay, so when as you can see a decoded PCM audio, the input is PCM. Okay, it's actually the output is encoder bit stream, the input is encoder bit stream. Okay, basically is the revert function, frequency in time domain, but then time to frequency domain, and this is frequency to time domain. That's all. Okay. Okay, next questions. MPEG have a variety of different standards such as MPEG 1, 2, 4, 7, and 21. Discuss, discuss why such standard evolve. Okay. Um, I think this is not in the lecture notes. Okay, let's see if you can answer. Han Xiang En, are you there? Okay. Jamming. Okay. Can you share your answer? One moment. MPEG 1 video CD, MPEG 2 DVD to ensure media conversion standards are widely accepted, widely adopted, universally available. Okay, thank you for your answer. Let me check. So different MPEG standards have been developed for developing target domains that needs different compression approach and now format for integration and interchange of multimedia. Yeah, something more or less like okay. Usually, we will always like a product of detergent. You have so many different brand of detergents. Why you want to choose this brand? Why you don't want to choose that brand? This is somewhat you have your pros and cons lah. Okay, but against as I always mention, multimedia in terms of multimedia, we don't usually have a superior. We don't usually have a best method. We don't usually have so. Maybe in these with all these constraint, multimedia A is the best, or method A or algorithm A is the best. But when the constraint is changed, usually the uh, types of method or types of approach would be different. Would be another things like okay. So this is something very common because we have the best fit actually, because after evaluations of the performance, comparison, benchmark, and etc., we usually have a best fit. But this best fit is only applicable with this, and these conditions, or this, and this constraint. Without this constraint, or once the constraints or the factors contributing to this system is changed, perhaps this is no longer the best fit solution. Okay, so basically, all these impact 1, 2, 3, 4, 7, 8, sorry, and 21 is to tally with different algorithm and different needs, like I would say, different needs. Okay, and it depends on the popularity as well. A very cliche example would be the JPEG and JPEG 2000. Or I think I've been mentioned so many times. JPEG 2000 is better in terms of when you compare with the JPEG. But nonetheless, because JPEG 2000 have the frequency and spatial domain information, but in JPEG only the frequency. But nonetheless, JPEG is more popular than JPEG 2000 until the manufacturer not even consider JPEG 2000 inside most of the OS. So that is the reason why, although you are very, I mean, more superior, but doesn't mean it would be widely accepted. Okay, so give an example, target application for each variance. I think Jamie already give the answer. So MPEG 1 was target for SIF video, originally optimized to work at video resolutions of pixel at Okay, but nonetheless, I won't ask such questions in your exam lah. Okay, um, again, because you are in the senior year, as I always mentioned, I will not likely, I mean, I will unlikely to test the knowledge that you actually can Google it. Okay. Of course, I would like to test you all, but of course, I will still include some of it, but not the core. The core would be how you correlate. For example, I mean, something like your lab and assignment. Uh, because you already done lab and assignment, I would ask something that require you to correlate from what you learn. For example, you say salt and pepper, and then you said median filter is the best. Why it is the best? So this for this one you have to justify. Um, of course, in lab and assignment you can generate the result. Nah, this is the best. No salt and pepper noise. But in exam, how should you justify? This is what I am seeking for lah. Okay, in your I mean, I would check for the do you really understand why you use median filter, why you don't use mean filter, something like that, because this is what uh unlikely to be Google lah. Actually, you want to Google this is still can lah. Just that you need sort of thinking lah. Unlike this one, MPEG 1, MPEG 2, basically you just type the example MPEG 1 will be all appear in Google lah. I think later on when you work, it's very easy for you. I mean, we always to be frank, working as an engineer, we always source the answer from internet. Is very common, and I to be frank to you all. Just that some of it you have to base on fundamental theory. Without the fundamental theory, sometimes you don't even know how to Google it. Okay, so I'm looking for this kind of knowledge in your examinations. So require you to think and correlate. If you say medium filter is the best, why and how? Okay, if you just write, medium filter is the best for salt and pepper noise, maybe just 1 mark lah. Because yeah, you are correct, but without any justification, or the justification is invalid, something like that. Okay. So MPEG 4, 7 and 21, yeah, something over here lah. MPEG 4 originally target a very low bit rate communications. 7 target multimedia content description interface, and 21 target a multimedia framework. Okay, something like that. Okay, so when you look into this 1, 2, 4, 7, and 21, it's target different applications. So this is the reason why that okay. when you have a product which is specifically for, remove the wrinkles of your eye from your eye. So basically that one, you call it as maybe serum or whatsoever. But if you have some lotion which is for multi-purpose, usually nothing, the lotion did nothing good lah, something like that. That is the trade-off. Is not so logic to have everything being optimized. If yes, the price must be sky high. Okay, so this is the, I would say, gold standard lah for each and every product. So state the video format used for analog color TV system and describe their characteristic. Oh, okay. This is just copy from the. I think I don't need you all to answer. Okay, this is just copy from the lecture note, and I will ask something like this one. Okay, don't worry. You don't need to memorize something like this. State the video format. So this is the scanline. This is the frame rate. Why I said I will not ask something like this, because this is so-called the standard. NTSC, nothing you can do. This is the scanline. This is the frame rate. And this is the scanline for PL and SECM, and frame rate will be 25. Okay, let's go to the next questions. Determine the memory required to store half an hour video from the digitization of CCIR 601 625 line system. Okay, this requires some calculations. I'm not sure if you can put the answer in the chat box. If yes, go ahead. If not, you can ask me to let you control the screen. Let me pick someone to answer. Xu Pianchan. Are you there? Okay. Do you want to use the screen or you want to put it in the chat box? Oh, okay. It's okay. Anyone can help. Mm, Yu Yang. Okay. But this question is more or less like how you calculate. But this question is more like how you calculate the frame rate and etc. I mean, there is another. How come? One moment. Let me see. Okay. Let me check the original questions. Tutorial 7. No, tutorial 8. Oh, okay. Determine the memory required to store half an hour video from. Da, 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 da. Okay. I think this one, uh, first of all, you need to know the number of lines. But I did not include this in the tutorial. But I think this number of lines is in the lecture notes. One moment, let me check the lecture notes. Lecture notes, where is it? Maybe in 11. Okay, CCIR 601. CCIR 601. Yeah, this one. Yeah, this one. So you have CCIR 601, you have uh, actually I mean, in terms of televisions or especially video we have the YUV or YIQ, as I mentioned just now in the wonderful lectures. Usually we have luminance channel and chrominance channel. The reason why we always I mean, why this kind of standard always like to use this color channel is that you can actually subsampling the chrominance channel and only process the lumina channel. Okay, so you can actually perform higher compression rate. Okay, so for this for these questions, it is asking CCIR 601. So CCIR 601 is this one referred to the last page in the chapter 10. So you have luminance resolution. This is your luminance resolution, and this is your chrominance resolution. Okay, so this value and this value, which mean resolution, which mean the x and y axis. Not really x and y axis, but the resolution of an image. So which is 720 multiplied by 576. And for this is for luminous channel. And for the chrominance, which is another two channel, it depends if it's YIQ or YUV or whatsoever. But luminance channel only one, chrominance channel you have two. So for the two chrominance channel, the resolution is 360 multiplied by 576. Okay. So let's see for the luminance channel signal. So you have set 720 multiplied by 576, which is from here. And for prominent channel, you have CBCR. Oh, so this is using Y CBCR. So the CBCR is this one. 360 multiplied by 576. Why 2? Because you have CB and CR, two different channels. Okay. So after you multiply, you get this sample and this sample, right? So later on, the memory required per frame would be this plus this one and multiply by 8. So you will get megabits. Okay. And then memory to store half an hour, which means 360 60 multiplied by 60. 60 multiplied by 60. Is it correct? Um, to store, one moment, let me see. 6 point, this value is getting from here, and 25 FPS is from FPS, where I get FPS, and multiply by 0.5, half an hour, so it's 0.5. So this is because 60 minutes multiplied by 60 seconds. 0.5 is for half an hour. 25 FPS. Let me see where can I get 25 FPS. Is it elsewhere asking 25 FPS? One moment, let me check this one. CCIR. I think the standard for CCIR 601 is 25 FPS. I think I include somewhere in the lecture notes. Oh, it's okay. I will get this info for you later on. But if not mistaken, the FPS for this standard is 25. So this is how you get the value. And then you multiply by, 10 power of 11 so that you convert it to GB. Okay. Any questions regarding this one? This is a bit tricky, I would say. But nonetheless, if let's say this is in the examinations, you would be given this value. I don't expect you memorize what is the resolutions for this standard. Okay. If let's say this question is given, the lumina and also chromina channel, the resolution would be given, and also the FPS will be given as well. Because I don't expect you. But of course, this one is not given because I already mentioned half an hour. So you should able to do this, and the conversion rate I will not given. But nonetheless, if the question did not ask you to convert, it's up to you to convert or not convert. For example, you want to remain your answer in kilobytes, or maybe just simply bytes is okay. Okay. But nonetheless, if the question asks for kilobytes, so please give me the answer in kilobytes. Okay. So any questions with regards to this one? Yes, no? Okay. I will upload this one to the Google Classroom later on. Okay. But always be extra careful when you convert bit to byte, okay, and um, converting to GB and etc. Okay, make sure you don't do the conversion wrongly, because it's not worth that you lost this kind of marks. And for the question number seven, actually uh, you don't need to do this question, because this is out of our syllabus. But nonetheless, this is just FYI. So I will not call upon you all to do this question. But do you know how to do question seven? Maybe I random pick someone. Chai Siu Chia. Are you there? Yes. Do you know how to do question seven? Maybe you want to share your answer. Okay, okay, it's okay. It's okay. Let me give you the answer for this question. Because we not really focus on the chroma subsampling. This is about chroma subsampling, but actually the theory to select the answer. I mean, this kind of answer is more or less same as this one. It's more or less same as the idea here. Okay, it's more or less same. So which means 444, you have all the or I mean, let's do a revision together in this part. The subsampling, the four is referring to this one, two, three, four, and another four is the first A block, another four is regarding the first B block. Okay, the row like A row and B row. So 444 is that all the color is retained, which means you did not perform any subsampling. So which means there no compression at all. So this is the 444. But nonetheless, the highest quality here means is that you retain the original quality. You did not really improve the quality, but you retain the original quality. Okay, so this is so-called the highest quality. Um, uh, because for the rest, for example, 422, 420, and 411, you are actually removing part of the informations from your chroma channel. So basically, there is no longer the original informations, whereby some of the information is already eliminated throughout the subsampling. Okay, so for this one, 422, you actually remove these two channel, I mean, not really channel, these two color, but you retain first and the third columns, starting from the left hand side, first and the third column. And the percentage of compression is up to 50%. Why 50%? Because two row out of four, two column out of four is being removed. So you have removed 50% of the image informations and retain another 50%. Okay, so for 420, you are actually removing all these cross I mean, which mean you has removed it. So the more reduced 420 take up two chroma sample from top row A. So A, because this two is referring to A, the another zero is referring to B, which means you get nothing from B, but you get something. I mean, you remain two color from A, which is this one. This the first and the third one. So instead, the bottom row share the chroma information from the top, which means you share something from here, lah. Okay, which means this blue color duplicate for all these four blocks, and this yellow color duplicate for the another four blocks. Okay, so this reduced the overall chroma information by to approximate 25% of the uncompressed chroma, which means you have removed up to 75% of the informations. Another one is 211. The rate of compression is same as this one, because you have 421, you retain two only, and this one 411, you retain two also, but one from the A row and one from the B row. So basically, this row will be duplicate for the entire, I mean, the blue color, the first blue color will be duplicate for the entire row, and the orange color here will be duplicate for the entire row at the bottom. So this is how this is being formulated. So this is also reduce the I mean, compress the images into 25%. I mean, remove up to 75% of the information. So this is the normal chroma subsampling we are using. And let's see. Okay, chroma subsampling is a method that store color information at lower quality than intensity information. So chroma subsampling is meaningful because human visual system is less sensitive to variation in color than brightness. The reason actually the chroma subsampling is, I mean, is able to remove a lot of information from the input image. But just that that is because I mean, the human eye is not sensitive towards the chroma channel. So that is why it's okay to remove all this information. But the human eye is more sensitive towards the Luma channel. So we will need to perform more sophisticated compression algorithm. We can't just simply, duplicate the color and remove it like 4:0 or this ratio. So chroma subsampling can reduce the bandwidth for color details in almost no preservable visual difference, which means after you apply the chroma subsampling, our human eye is not really can um, identify the difference. But of course, when you scrutinize your image in details, you would found, for example, the top which are original without chroma subsampling, you can see a very clear cut of this, a very clear cut of the edge. But when after you perform the chroma subsampling, you will find something like this one. Okay, so this is the effect from the chroma subsampling. Okay, and it is very obvious, especially at the edge or to present some of the details of the information of the image. And especially it is when dealing with color, like green, purple, red, and blue, different color. If this is black and white, then of course it is not obvious. Okay. So chroma subsampling for 2:2, basically 2:2, which means you get two different, um, 2:2, which means you can actually refer to this one, 2:2. So which means you will remove this one, get this one. Okay. Okay. So this is so-called 2:2. So you will get something like this one. Okay. Which is within this one. You remove the second column and the fourth column. And for 1:1, you can refer back to which one? 1:1, this one. So remove everything, only the first column. So this is very simple. Only the first column, you remove the rest. Okay. And for 2:0, let's see this one. 2:0, you remove the bottom one and you retain the top one. So remove the bottom one. Oh, let me remove this one first. So you have the original like this one. So you remove the bottom one. Remove the bottom one. And what else we remove? And remove alternate one. Okay, so this is your answer. You can see this as one line. This is one line. Yeah. Okay. So this is how you actually get the value 4:20 and 4:11 and 4:22. Actually, you are getting to some extent, most of the image processing algorithm, you are identify the patterns. I would say identify the patterns. It is like the arithmetic, and I think I think this is from Form 5, AP and what I'm not sure if you all can recall. In Form 5, we have so-called, identify the patterns, right? In mathematics especially. I think it's AP and AG or what? Yeah, AP and GP, something like that. So this is actually derived somewhere from there, like, to identify the patterns, and then this pattern is being duplicate and duplicate, and then yeah, this is actually all these things is quite interesting. It actually correlate to many of the fundamental in Form 5, especially. I would say Form 5. But of course, if you do take Form 6, you will find that it's more advanced, especially. So, yeah. So actually, I mean, if you go for Form 6 and after Form 6 you come to degree, you will find the degree is much more easier, especially in your junior year. Yeah, because I'm from Form 6. Yeah, at least I shared the same thoughts, lah. Okay. Any questions for the tutorial 8? Why is multiplied by 8? One moment. Actually, for some seconds, I mean, for a second, I did think about this as well. Why multiply by 8? This one. A moment. Memory required per frame. Um, Memory required per frame. What I can think is that because each of the pixel consists of 8 bit, 8 bit it should be the, because it is asking for memory, it is not asking simply the rate or the size. Um, but this one I need to check back the reference book first in order to confirm you. But if not mistaken, the 8 is the bit required for each of the pixel to hold the informations. Because you have 8 bit, right? 8 bit, so that you have 0 to 255. So still, since you have 3 different layers, so that is why you have this one from the Luma channel, this one from the Chroma channel. So add up all together. So this is sample is also the pixel, the number of pixel. Because after you multiply this, you will get the number of pixel, right? The number of pixel in Luma, the total number of pixel in 2 Chroma channel, and then you multiply by 8 bit, because 8 bit consists of 0 to 255, right? So each of the pixel is holding 0 to 255. So yeah, I think this is the reason why. But even sometimes I check back the reference book, and perhaps I will post in the Google Classroom to answer your questions, because I need to reconfirm this one. But nonetheless, if not mistaken, it is referring the memory required to hold the value of each and every pixel, which is 8 bit. In this case, 0 to 255. 0 to 255. And then you will get this number of bit, and then you multiply by the FPS, the time taken. Yep. For okay, Gasing, I will reply you in the Google Classroom. Let me confirm first. 422 sampling, 422 sampling, 422 sampling should be this one, right? This is 422 sampling. Why 22? Okay, let's see this one. 22, you retain this and A and B, right? But you remove the second column, right? So back to here. Oh. So back to here. Let's say this is A, B, this is A, B. So the second column don't want, the fourth column don't want. So you can see it as one set. This is another set. So you will get this value, AB. Let me, okay, so AB, so get this value, and another AB, get this value, and the third row, sorry, the column, this one, and this one. So that is why you get this answer. Okay. I thought is the 8 is because of 422. Let me think. The 8 is 422. Oh, okay, okay. You are talking 422, so it's 8. Okay, let me look back in the questions. It is 422. But if it's 422, is you shouldn't be adding this one, right? Because 422 only perform is the in the chroma channel, which is this one only. If you but it's I mean it's not logic lah to multiply by 8 from 422 because after remove for 422 you actually remove 50%. So it's not logic that this one multiply by this and plus this. Okay. So I don't think the 8 is because of 422 lah. Okay. I lost my connections. Can you hear me? Okay. Okay, so I think it's not so logic lah. It is because of 422, but perhaps I think it is because of the number of bit lah. Okay. But let me find the reference book first to reconfirm you on this one. Okay, I try not to do any more gaps. Okay, so any more questions regarding the tutorial? Except for the questions. What question is it? 6. Yeah, question 6. Yes, no. Sir, could you upload the? Of course. I will upload this later on. Yeah, I will upload this later on. All the previous tutorial and solutions is in the Google Classroom, so you can go and get from there lah. But of course, I think I already upload until up to tutorial 7. Tutorial 8 and 9 not yet. Okay, you can check your tutorial questions over. I mean solution over there. No, no questions. Okay, if none, so that's all for today. And always, reminder again. Please check your lab and assignment. And if you have any questions, email me. And please do so before tomorrow, before 5 lah. Okay. After I submit, key in the marks. So no long. After tomorrow 5 p.m., I will no longer entertain any requests lah. Okay. So yeah. Okay. Thank you so much. Stay safe, everyone. And yeah, bye bye. Oh, is it? Let me check. Yeah, I will upload later on. Let me check if I check back first. If let's say I forgot, so I upload later on. Thank you, Ernest.